Yeah, before we dive into the topics that are right now unfolding, like potential fragmentation of the 3i Atlas, I want to start with a general question. I read your article, Preliminary Anomalies of 3i Atlas. I read almost all your articles, but also that one. And I quote, in that article you wrote, "The simplest hypothesis is that 3i Atlas is a comet. However, we will be faced with the tantalizing possibility that it did not inherit a random velocity, but instead was sent by design." My first question would be, how would we describe the scientific process of distinguishing between a natural object and a designed one? What kind of data do you expect to see that could clarify this?
Right. This is an excellent question because sometimes in life you encounter events that are low likelihood. Just to give you examples, the first gravitational wave signal was obtained from a pair of black holes, and it was detected by the LIGO experiment back in 2015. And since then, this was perhaps the most clear signal that we ever detected because it was a very high signal to noise ratio. The LIGO experiment also discovered two neutron stars merging, and that was early on, a couple of years later, and that since then we've never discovered such a clear signal. So sometimes things happen by luck. I met my wife on a blind date, and the question is how to quantify the likelihood of something happening. And in the case of 3i Atlas, there are really several unusual anomalies. First of all, its size and mass. So right now, my best estimate is that its size is bigger than 5 kilometers, and that's based on the mass that it needs to have, 33 billion tons, in order not to be deflected for 5 months before October as a result of its mass loss towards the sun. It was losing mass, and there was no recoil as a result of that. So from that, you get that it needs to be very massive. But the problem is that then you get that its mass is 1 million times more than the mass of the first interstellar object. And given that there is a limited reservoir of material, we should have seen 1 million objects like the first one before we see one giant object like the third one. So that's surprising. And I did also a calculation that demonstrates there is not enough material in interstellar space to accommodate the delivery of such a big package in a decade of surveying the sky. We would expect it once per 10,000 years. So the statistics of that is easy. Basically, you're saying, okay, we observe for 10 years, and we expect it to arrive once per 10,000 years. Therefore, the probability is 10 to the minus 3. Okay, and so 0.1% that we will be that lucky, which is really surprising. And then the trajectory of the object is aligned with the planets with a probability of 0.2%. Again, so you say, okay, let's combine just these two facts, not worry about other anomalies. We're getting a very small probability of, one part in 100,000 or so. And so then what do we do about that? Of course, it's possible. And by the way, the astronomers who argue that it must be a comet, they don't really address that issue. They say, well, the comets sometimes have strange properties, but this is not a matter of strange properties. This is a matter of the mass budget, the likelihood of a trajectory that is aligned with the planets. When we expect, for example, the galactic disk is 60 degrees away from the plane of the planet. So that's, I would say, these are serious concerns that have to be addressed if it happens to be natural. Yeah, why are we are missing something. Maybe there are factories of interstellar objects like 3i Atlas that we are not aware of. They have to bring such objects that are big in the plane of the planets, but we don't know why, and we need to figure it out. If it's natural, there needs to be a reason.
Sure.
Well, I think this is an excellent question, because one thing you find from critics is they say, oh, rare things happen, we don't know, and they just dismiss it under the carpet of traditional thinking. And I think we cannot do that. We have to explain it in order to feel comfortable.
Sure. I think at this point, almost everyone agrees that it is an extraordinary object.
Right.
But yeah, like you said, a lot of scientists say, okay, these anomalies that we've seen can be explained by natural causes, and some of them already have been explained by natural causes, right? I think the first color shift, for example.
Yeah, go ahead.
And so these critics might say, don't you think that also the other anomalies, the unexplained phenomena that we have now, that they can also be explained by natural causes?
They could, and I'm not. I'm actually. I would love to know the explanations, but what I'm arguing is we should not dismiss alternative interpretations while not explaining the anomalies. So what influencers like Brian Cox or Neil deGrasse Tyson are doing is basically saying to the public, it's a comet, that's it. They ignore the anomaly. They are not explaining. So science is not done by authority, not by making a statement and wanting everyone to believe it. The way the Vatican said about the Earth being at the center of the universe, you can make that statement, you can use as much force as you want, but the Earth was moving around the sun 4.5 billion times before the Vatican even existed. So the Earth didn't care about it. Whether we have a neighbor or not does not depend on which opinion is more liked within the human species. That's irrelevant. We want to figure out the thing, and therefore we should explain the anomalies if we want to make progress in our knowledge. Just saying that it's this or that is not really productive. It doesn't teach us anything. It teaches us something about human psychology, perhaps. And one question I was asked actually a lot is, why are the experts so dismissive of alternatives? And I explained that they are just like AI systems, that we train on some data set. So all the experts were trained on a data set involving comets. So anything in the sky should be a comet, even if it's an object like Oumuamua, which does not have any cometary evaporation, no gas or dust around it, yet it exhibited some non-gravitational acceleration. So what did the experts say? It's a comet that is dark. It's a dark comet, which is basically, you're saying it's a comet without the features that characterize a comet. And that's an oxymoron. And a spacecraft would be just that. When you have a spacecraft, it has no cometary tail, so you might call it a dark comet, and that's inappropriate. So my point is, we should not pay too much attention to what people say. Let's just keep our eyes on the ball, which is 3i Atlas.
Sure. Yeah, I know this topic of dark comets is really funny, because this term didn't even exist before. So it was invented to describe Oumuamua because it didn't fit the descriptions of the comet.
My point is, it's like experts on zebras that go to the zoo and see an elephant, and then they say the elephant is a zebra without stripes.
I mean, it kind of is, but
well,
really.
My point is a completely different animal.
Sure, definitely. Yeah, I agree. Okay, then let's talk about the properties of 3i Atlas. I read one of your latest articles in which you spoke of potential fragmentation of the object while it was, from our perspective, behind the sun. Could it really be that it is now not just one piece of comet or whatever, but a lot of fragments? And that's the
result I derived yesterday morning, because there was a new image obtained by some German amateur astronomers, actually, and the image showed jets coming out of 3i Atlas, the nucleus of it, extending to millions of kilometers away, and some of them were going in the direction of the sun. And so that means they were able to penetrate through the solar wind. It's a headwind. The solar wind is moving at the speed of about 400 kilometers per second. And if you assume that the jets are emanating from a comet, meaning they move at the characteristic thermal speed of molecules from the surface, which is 0.4 kilometers per second, that's 1,000 times slower than the solar wind. That means the mass density of the jets needs to be 1,000,000 times bigger than that of the solar wind. And we know the density of the solar wind. So I calculated that the amount of mass that had to be carried by the jets is of order 5 billion tons, okay? And then you ask a simple question. If you want to sublimate ice, let's say carbon dioxide ice, which is easier to sublimate than water ice, you need less energy. So I took the most favorable case. Then there needs to be a certain surface area that is exposed to sunlight in order to get enough energy to evaporate it within a month, during the time of passage close to the sun of 3I Atlas.
Mhm.
And I calculated the surface area has to be that of a sphere that is 20 kilometers in diameter, very big, much bigger than expected for 3I Atlas, actually. So that means the object might have broken into pieces, because if you break a big object into small pieces, there is much more surface area exposing the material to sunlight. So in the case of a natural comet, I would be very interested to know if indeed the object broke up, because that is the prediction based on the amount of mass carried by the jet. Let's just wait. In the coming weeks, we should be able to see, because if there are fragments, they will get separated by the tidal force from the sun. The gravitational tide from the sun would separate them, and we would see individual clumps. So in the case of a comet, that would be a very natural consequence of heating by the sun, and we would know the composition of the material that was in the body of the comet, because now it's broken up. There will be no doubt that it's a natural object. So that's a clear test. However, if we see that the object maintained integrity, and we are also able to measure the speed of the jets, and we find that it's actually much bigger than 400 meters per second. For example, chemical rockets that we use have an exhaust speed of a few kilometers per second. So that's a factor of 10 more than the volatiles evaporating from the surface of a comet. And ion thrusters reach another factor of 10. So an alien technology thrusters might use even bigger speeds. So when you are using higher speeds, you need much less material to be ejected to get the same momentum. And so as a result, if we measure with spectroscopy the speed of these jets and find that it's much higher than expected, we would know that they were produced by technological thrusters. And that's a clean test. So if we see an object maintaining its integrity, we measure the speed of the jets and the mass density of the jets, and we realize, wow, that is really surprising, unusual for any naturally produced, jets from pockets of ice on the surface of a comet. Then we would know it may well be technological, and this can be found in the coming weeks, because as of today, 3I Atlas is separated from the sun in the sky by 30 degrees, and that is the critical angle. Once it goes beyond 30 degrees, we can observe it from Earth without a problem, and we will have hundreds of observatories looking at it. The International Asteroid Warning Network decided to have a campaign that involves hundreds of observatories between November 27th and January 27th. So, as a scientist, I love as much data as possible. I want to be flooded with data. People who are sort of, they want to maintain their prejudice. They don't like data, because data may threaten their knowledge, and change their opinion.
So I would say that our best chances are Earthbound observations, because there's a lot of talk about also these space missions that could now maybe have a look at 3I Atlas, like JUICE, which is on its way to Jupiter,
right?
Or maybe also Juno, which is already there.
That will be helpful. There is also the end of the government shutdown in the US. And this morning, I was encouraging NASA to release the images that were taken by the HiRISE camera on board the Mars Reconnaissance Orbiter, because these have pixel resolution of 30 kilometers. So hopefully, we will get some additional data, but I think the highest quality data will come from the Webb telescope, the Hubble telescope, and ground-based telescopes. And on December 19th, the object will get closest to Earth, not very close. It's 250 million kilometers. So this object avoided us, by the way. It was on the opposite side of the sun when it came closest to the sun. So the sun was between us and the object. We couldn't observe it, perhaps for a reason. That's another coincidence. But we will get much more data about it as it moves out of the solar system. And the fundamental question as far as I'm concerned is whether it could have been a mothership that released some probes, in which case we might find some unusual objects close to Earth or close to Mars in the coming months.
Mm-hmm. Yeah, one of the best arguments I've heard against the alien probe hypothesis is that probably there are like millions or even billions of interstellar objects in our solar system. We just aren't able to detect them, right? And
well, when you say probably, just imagine that a person approaches you on the street and you would say, well, I look at there are billions of people on Earth, and obviously there should have been a person next to me, but that's not necessarily the reason. The person may approach you because that person has some intent. Okay, so when you see an object coming to you, you can speculate that there are lots of objects. It's completely random. But no, if this object has some intelligence behind it, the reason it approaches you has nothing to do with the billions of other objects. And that was my point about the mass budget. If there is not enough material in interstellar space to accommodate the delivery of such a giant object made out of rock, then maybe this object is not drawn out at random out of the mass reservoir of rocks. It's actually targeting the inner solar system. And that was the whole point. So the fact that there are other objects is completely irrelevant. The question is, why is this object here right now with a low likelihood for its trajectory, with a low likelihood for its mass?
Sure, makes sense. But maybe I'm poking a little bit. Wouldn't it make sense then also to do a flyby at Earth? Because, I mean, you could say that it's the most interesting planet in the solar system. I don't want to seem arrogant, but
that's the self-centered view. So, we tend to think everything is about us. Like my daughters, when they were young, they were at home and they thought the world centers on them. And then they went to the kindergarten and realized, and they sort of matured as a result. And so my point is, we initially thought we are at the center of the universe. Then we realized, oh, wait a minute. No, actually, the Earth moves around the sun, so we are not at the center. But we still think that if aliens come to the solar system, it's because of us. The answer is no, because we existed just a few million years, which is 1 part in 1,000 of the age of the Earth. And, if they move at 60 kilometers per second, like 3 Atlas moves, they must have started the journey a billion years ago, much longer than, and so they embarked on this journey unrelated to our existence, and their goals might be very different than we can imagine. And it's really foolish of us to assume that we can guess what the technologies are being used and what kind of purpose there is, because all of this is self-centered and our imagination is limited to the learning data set we had on Earth. And there is vast amounts of real estate, space, and time beyond what we experienced. So, our imagination, or the imagination of script writers in Hollywood, I argue is much less than what nature may provide us with on a blind date.
Yes. Yeah, I mean, it makes sense. We are just here for a few million years. I think Homo sapiens exists just for, I don't know, way less than that. So yeah, our view is definitely a little bit restricted. Let's say that.
And also documented human history is only 8,000 years old. So we don't know if there were visitors that were not documented to Earth while the early humans existed. And yeah,
that leads me to a question of one of my viewers. I found really interesting. The question is, if we imagine for a moment that we are at this aware of artificial intelligence origins, how advanced would the civilization behind it have to be? That touches a little bit the things we just discussed. In my opinion, it doesn't mean that we deal with a civilization high on the Kardashev scale. Because, I mean, we've sent probes with the Voyager probes, for example, who will at some day reach another star system. When they're behind the Oort cloud, they will someday be in another star system. So you don't have to be so advanced to do this.
Right.
What do you think?
So my view is we are not at the top of the food chain in the Milky Way galaxy. Let's give up on that idea, because we had only 1 century of science, modern science, since quantum mechanics was discovered, the general relativity was discovered, and they may have had millions or billions of years of technological advances that make them highly superior to what we are. So as a result, we should use it as a learning experience, and rather than imagine that we can forecast what they might be like.
Okay, then let's maybe talk shortly about the other interstellar objects. 3 Atlas is, like the name says, just the third interstellar object we have discovered. We had Oumuamua and Borisov. Would you say, or what makes 3 Atlas maybe more remarkable than these two? Nobody talks about Borisov. I don't know why, but I know that you talked a lot about Oumuamua. What are the differences between 3 Atlas?
So Borisov was a comet not very different than the comets we're familiar with in the solar system. And Oumuamua was also anomalous, but in different ways than 3 Atlas. It didn't have any gas or dust around it. It was most likely flat in its shape because the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. We don't see variations of brightness that are that significant in 3 Atlas. And it has a cloud of gas around it, so it's very different. But Oumuamua was pushed away from the sun by some mysterious force. It definitely exhibited non-gravitational acceleration, just like 3 Atlas is doing now. And the question was, what is pushing it? There wasn't any clear evidence for a rocket effect doing that. So that's what intrigued me, and I suggested maybe it's a technological product. And now, it was also 100 meters in size, in length, which is comparable to the biggest rocket that humans ever built, which was Starship that we currently are studying. And on the other hand, 3 Atlas is 5 kilometers or bigger. It's the size of a city relative to the size of a football field. And we just have no idea how you can launch a spacecraft that is as big as a city. Now, of course, once we realize that other civilizations may have done that, if we have clear evidence, then we might be inspired to do that. And that may be the right way to bring people out of the Earth, in a habitable spacecraft that they can occupy with artificial gravity, if it rotates, if there is some spin, and you need to produce enough power to fuel it. And so my guess is that once we realize that there is a technological visitor, and there could be some potential threat to humanity, to Earth, we will invest a fair fraction of the military budgets that we currently allocate to conflicts on Earth to space exploration. So we might allocate maybe $1 trillion a year worldwide to space exploration. That means we can put the architects, engineers, scientists on a project to construct a spacecraft that can carry humans for a long journey, even out of the solar system. And to me, that's a much more visionary concept than going to Mars, which is just another rock. It's a much worse rock to be on because there is no liquid water, no atmosphere. So why would we go from the conditions we have on Earth, which are so much better, to a desert like Mars? We better build a space platform that can accommodate humans. So I see that as the next step, but I don't see enough money being allocated to that vision until we would realize that we have a neighbor that is much more accomplished.
Yeah, speaking of worse rocks, maybe to wrap things up, because I think you just have 5 more minutes, I would like to briefly speak about one other idea of yours. I made a video about it actually a few years ago. You wrote an article or even a paper about the moon as a possible place for alien debris or something that came from outside the solar system, which then landed on the moon. I found that idea really interesting because
it's like a museum, because
exactly,
on Earth you have the atmosphere that burns up anything that enters, whereas the moon collects everything on the surface.
Yeah, so that would, because we don't have so many chances to find these objects from outside the solar system, right? 3 Atlas now is one chance, but they don't come so often. So the moon would be a good place to have a look.
Either the moon or Mars. Mars also had 2 billion years without an atmosphere. So we should do archaeology on the moon or Mars, look for objects that were accumulated over the billions of years on their surface. And that means also clearing the dust, not just looking from a distance, because there might be a lot of dust on top of whatever crashed into those surfaces.
Yeah, that would have been my question. Under all the regolith and the dust and rocks, for what should we even look? I mean, we have no idea.
Well, the other thing I would be curious about is going to the caves. There are lava tubes on Mars and checking whether there are any prehistoric paintings on the walls of those caves. Because if intelligence developed on Mars twice as fast as on Earth, it means that maybe there was something there that preceded us as intelligent creatures.
Yeah, there are some cool ideas to explore these lunar caves. For Martian caves, I don't know, but they built some robot designs. So maybe we will get some insights in the future.
Right. Now, the moon never had the habitable conditions because it's too small, but Mars did. And, we can send a drone into one of these caves and image what's inside.
Yeah. Okay. So I think our time is almost up. I don't want to steal too much of your time. So maybe as a last question for everyone who now wants to learn more about your cosmic ideas, let's say, where should they start? I see your book behind you.
Yes, I have 2 popular level books, Extraterrestrial and Interstellar. I have several professional books that I wrote about the first stars, the first galaxies, and also the search for life, scientifically speaking. But I think the most exciting developments are recent. For example, with respect to 3i Atlas. And if you go to medium.com, that's an outlet where you just search for Avi Loeb on medium.com, you will find my essays there on a daily basis. And you can subscribe for free. I don't charge anything, and it's open to anyone. And by now, I just crossed the threshold of 100,000 followers there. So
congratulations.
Thank you, because it's very different from example from X, where a tweet just takes a few seconds to read. Here, the essays it takes 5 minutes or so to read. So I'm really glad that people are excited about science, and I get routinely messages saying, from mothers or fathers that say that their kids are now excited to become scientists after being exposed to my television interviews, podcasts, and essays. So actually, speaking about a podcast, there was a recent podcast I was on with Joe Rogan that people might find of interest as well. But in general, if you just Google my name, there will be a lot that you can find there. And altogether, I mean, I feel that this is an amazing opportunity. 3i Atlas is an amazing opportunity to get the public excited about science and support science, because it can address questions that everyone cares about that could affect our future, the future of humanity. And my hope is, if we discover an alien artifact, it will inspire us to do better. I feel when reading the news every day, I feel that I'm participating in a party where the attendees are misbehaving.
Yeah.
And my only hope is that there would be a guest that will improve the situation.
Yeah, well said. Well said. Okay, Professor Loeb, did I pronounce the name correctly?
Yes, it's actually German in origin. So
yeah, no, because in German you would pronounce the O-E Loeb, but that's wrong.
Right, exactly. That's the right way, and with an umlaut, actually. And my father was born in Germany, left at age 11 in 1935, and I actually went back to the village where he was born, and the family was there for 700 years, and
wow.
They just left before the Second World War. And
good timing.
Good. Well, that's my grandfather. He could see. I mean, there is a story I can tell you just in a few seconds. He participated in the First World War on the side of Germany against the French and fought in Verdun, which is a very famous battle, and was among the survivors. They were stuck in the mud for a year. And anyway, so one day in 1934 or so, there was a gathering in his town, and one of the members of the Nazi party stood up and said, the Jews are using up our society, and we should do something about it. And my grandfather stood up and said, how dare you say that? I fought for Germany in the First World War, and you dodged the draft. The guy was actually a communist. And so this person said to my grandfather, he said, Mr. Loeb, we all know about you and appreciate you. I'm talking about the other Jews. And,
sure.
And at that point, my grandfather said, okay, we are leaving. And there were 46 family members who said, no, we will leave at the last train. We believe that nothing bad will happen. And they left in the last train, but none of them survived the Holocaust. So my grandfather had the vision and the courage to do the right thing, and that's why I exist. Wow. And I'm actually I'm called after him. My name, his name was Albert Loeb, and there is actually a street called the Albert Loeb Weg. And if you Google it, you will see that's the town where he was born.
Incredible.
And so I'm called after him, and I still have a watch that he used to wear. Wow. And I had also some things from the First World War that he left behind. When I saw a movie about the First World War, it looked very authentic and similar to what I heard about him then.
Yeah, it's crazy.
Anyway, but I would have been in Germany if all of this did not happen.
Yeah, but it's great that your grandfather had the courage and the vision to leave, because many had not. And in hindsight, it all seems so clear, right? But it's never clear.
It's never clear. It's never clear.
There are always people who see the signs, and good for them. So yeah.
Well, most people operate by wishful thinking. They just and anyway, but when I grew up, my father never had any negative feelings about Germany, because he didn't experience any of the bad aspects of the Second World War, and we always had a German car, and he would listen to Strauss music. But he didn't teach me German.
Okay. I mean, at least you have still the German name.
Yes,
also when it's now pronounced Loeb. That's okay.
I was just in Germany in Schloss Elmau a couple of months ago, which is a very nice place where the G7 was held several times. And I talked about the latest results that we have in the Galileo project that I'm leading. Anyway, it's a great pleasure, and thank you for the excellent questions. I really enjoyed the conversation.
Thank you so much, and we're looking forward to the feedback of the viewers. I think it will reach a wide audience, and thank you so much for taking your time in this stressful time.
My pleasure. It's a great pleasure speaking with you.